We have to import random. We have to have a variable that goes to the random library and uses the function randint, and then has the arguments of minimum and maximum. Then we could create a conditional or a set of conditionals that are going to print something based on what random integer is put in there. So we're going to look at the code in this demo, and right now you have mostly a blank slate other than the import option and the variable for choice coming from rand int. Okay, so we have three things that we could print: a programming fact, a nature fact, or a miscellaneous fact. So if choice equals number one, if that random function gives back choice or gives back a 1 as choice, it's going to print the first programmer was Ada Lovelace, born in 1815. Then if choice is 2, okay, that's the nature fact, and it's going to print pineapples take 2 years to grow. Yes, 1815. Ada Lovelace. There, that's as big as I can make that. And then if it is number 3, it's going to print peanuts aren't technically nuts. That's the miscellaneous fact. So once you get that in, I want you to run the program, and I want you to run it over and over until you get each of those 3 statements to print. And I want you to tell me how many times it took for you to run it in order to get all 3. It took you 3 times? 7. Anybody take more than 7? Or we're not there yet? Okay, 7. It took me 8 last period. 1, 2, 3, 4. Really? 5, 6, 7, 8. 9, 10, 11. Did I forget something?
You don't have bad luck. Keep going.
12. There it is. On the 12th one. So that's the longest it took me. 12. Anybody get more than 12? How many of you did it only take 3? Raise your hand. 2, 3, 4. Okay. All right. So you see that it comes back completely random then. All right. So with random choice, we can put all of our options for outputs in conditionals, use a random number to randomize which conditional we hit.
So it doesn't matter if we use if or ELIF?
Probably not. I'm trying to think of a reason why it would matter. I don't see why it would matter. No. Okay, so basically, if a number does one thing, it's going, or if you get one number, it's gonna do something. If you get a different number, it's gonna do something else. Okay, make sure that you submit that one. And then we're gonna go to the other demo, which is weighted choice.
Wait. Can we just do the random phrase of thing that they give us in the library?
The random choice list.
It's going to depend on what it is. I mean, yes, if there's functions, yes, but I don't know what that one is. Did that one show up there?
No, a random
So-
choice list, we were able to use that for, when you were here, we used that for creating the invention.
And it was in the random library?
Yeah.
Okay, let's look. So we
Random
have,
choice or random choice list.
so it's not,
It wasn't there, I had searched up, random library on Google.
oh, you did? Okay, I'll look, so you called it random choice.
Random dot choice list.
It should be in random.
It should be random,
Mine's in random.
All right, I'll look it up and get back to you. Okay, so let's look though at weighted choice. Weighted choice is similar, but it's a little bit different. And with weighted choice, it's going to change the odds of how likely it is to happen. Okay? So, instead of it having to match specifically one number, if we want it to be more likely to happen, we have a wider range. So, we give it a minimum and a maximum that's a bigger range. If we want it to be less likely to happen, it's got a smaller range. If we want it to be really rare, we give it a really small range, or maybe have to make it equal to 1, okay? So this is something that we do like when we did the archery game, and it popped up with a bullseye. That bullseye is a smaller target, so it had a smaller range, but the big circle around the outside, a bigger range. If you want to do a genetic simulation on what traits are most likely passed on, that could be this. You can have a user input change the likeliness of an outcome. You can have a carnival style of games of chance, weather predictions, fantasy football simulator, and lottery tickets. So let's say that I brought you guys a dozen donuts, and 3 of them are chocolate and 9 of them are glazed. If you were to blindly grab a donut, which kind are you more likely to grab? Glazed? Why? Because there's more of them, right? Okay. So what about if I reorganize them so all of the chocolate are in one spot? Are you still more likely to get glazed?
Yeah.
Yeah, because there's still more of them, okay? So if you grab donuts 1 through 3, you'll get a chocolate. But if you grab 4 through 12, you get glazed. Doesn't mean you can't ever get a chocolate. It's just less likely, okay? So how can we use a range of numbers to make one outcome more likely than another? So here you have your code, your structure. You have your variable, your random.randint, and then you have a min and max, okay? Remember, those are your arguments there. We are just building on our random choice technique to make some of the outcomes more likely to happen. We could give the ranges in our conditionals, giving a larger range to the more likely outcomes, just like in the donut example, okay? So let's switch over to the code, which is mostly blank. You'll see that you have 3 parts to it. Most likely outcome, uncommon outcome, and rare outcome. So basically what we're doing is our goal is to program or is to write a program to open a mystery box. Each potential prize has a different likelihood of being inside. So if we are going to have something that is most likely outcome, you know that you always lose, right? Most likely outcome. So your most likely outcome is going to say the box was empty. And that's going to have the widest range of numbers that it can hit. So if 0 is less than or equal to num, which is less than or equal to 6, then the box was empty. Okay?
Wouldn't it be 1 through 6 because there's no 0?
You know, I was thinking that as well, and I'm not sure why that was put there. I'm not sure why that was put there. So the fact that it says less than or equal to, it makes it safe. But yeah, I was thinking the same thing. But I also noticed that this particular lesson had several like typo / grammatical errors in it. So I'm wondering if like somebody just didn't proofread this whole lesson. I don't know. Okay, so the less common outcome would be a smaller range. So this range is 7, less than or equal to num, which is less than or equal to 9. So unlike line 12 that had 0 through 6, this has 7 through 9, and they get a cool prize because they were less likely to happen. And the most rare outcome then is if your num is equal to 10. Then you get a grand prize. Now, run the program 5 times. See how how often different outcomes are triggered. You can continue running it until you get the grand prize, but since it's a 1 in 10 chance, it may take running it many times.
So it doesn't even have to be in order. It just needs to be a singular digit.
Say that one more time.
Like I could have num is equal to 7.
Yes.
Everything else would just have to be.
Yeah. You could have made your magic grand prize number 7, and then made 8 to 9 as your or 8 to 10 as your uncommon. Yeah, absolutely. Okay, but see, run it 5 times. I have the box was empty. Box was empty. Oh, I got a cool prize. Oh, I got 2 cool prizes. And the box was empty. So 3 to 2. But if I keep going, on number 6, I got the grand prize. I am definitely not that lucky in any other game that I play. So I'm going to stop right there. Okay, so does this make sense how this part is, the weighted choice is different than just doing a random number or random choice? Okay, so I have here in the lesson plan, we have 4 practices, 2 for random choice, 2 for weighted choice. Absolutely everybody finished them with time to spare in the last class. So I want you to work on them quietly by yourself. If after you work on it quietly by yourself, you're stuck, please reach out and ask me or someone for some assistance. And also, I want you guys to remember that you must submit at the end of each one.